Desk of Ladyada.
Hey everybody, and welcome to Desk of Ladyada. It's me, Lady Ada. It's a nice Sunday, and I've been working on some electronics. I thought I would just show off what we are working on here, some stuff that we got going, some things we're revising, and then we'll do a great search. So let's go to the overhead. We can pick up where we left off. So last week we were talking about tester revisions, and so there was tester brains that I use for. I don't think I have one handy here, but the tester brains that I use for programming SWD and RP2040 boards and even some ESP32 boards, and was originally based on a TNC 3.6, but I can't get TNC 3.6s, and so I was like, you know what, I'm going to revise. Stop freaking out. I was like, I'm going to revise this to use an RP2040 Pico, because those are really easily available, and it's about the same speed-ish as a TNC, has lots of GPIO pins, and is Arduino compatible. Plus, we have a very simple USB host stack for that's bit banged on the RP2040. So you can do basic enumeration checks, which is part of how I test boards. So it's actually, it's kind of important to me to make sure that whatever I replace that TNC36 with, it could do USB host, which is why I'm not replacing it with, a 7021 or 7051, because they can do USB host, but only on the main USB port, and I need that USB port to remain available. It needs to be a secondary port. So this is the board. So, put it together, plugged in the Pico into the sockets, plugged in the TFT into the socket, and wrote some code. I got the piezo here, the USB host, SD card to hold firmware. This is, the two device under test connector. So this connects to this Gemma board, which has the same pinout. And then, you can plug and play different boards depending, if you want to test a feather or a trinket. This part stays the same, and then this part changes. It just makes it easy if this breaks, because, this microcontroller can easily get fried or, destroyed, or it's static, or coffee spilled on it. So this demo code here is pretty simple. What's interesting is the RGB backlight actually didn't have enough pins to have a full RGB backlight. So there's a WS2811, right, which is a NeoPixel chip. And it's right under here, you can see it, and that's how I'm driving the backlight. Then I'm just running, the NeoPixel PIO code on there, but it works wonderfly. So it's actually kind of nice. It gives a nice, good constant current color, no matter what the power supply is. The SD card, because it doesn't have onboard SD, and then the USB host. So at my computer, I started drafting a library called, Tester Brains that would simplify some stuff. So I can LCD printf, and it will do the right thing. And I can say, if SD detected, begin the SD card, and, kind of just wrappers it a little bit to make it a little bit prettier than just, trying to avoid having these massive long programs where every pin is redefined over and over again, because I'm going to be using that same brain PCB. And then over here we've got the output, and you can see it's hey, I'm detecting the SD card, and it prints out the contents. And we're using the SDFAT library, which is really great because it has long file name support, which I find really handy, because otherwise if people are trying to,
Let's see.
I don't know where I was last.
Yeah, keep
talking.
going.
Okay, well I'll just restart the USB chip chat. Basically, the SD card, long file name. I think I chatted about how we have long file name support, which is really good. I like that. And then the next step was testing the USB host, because again, I like to test the USB connection. It's a really good way to verify that the right program was loaded, because the VID, PID have to be right. And also we want to, program some chips over USB, like the RP2040 There is a SWD interface to the RP2040, but it's a dual drop, and it's like more complicated than just most SWD programming that we support. So we'd like to use the USB interface, and on the TNC36 we used mass storage. We're not sure that we can bit bang mass storage because it's I don't know like how picky it is about errors or just dealing with mistimings and stuff. Because it's bit bang, it's like it's not going to be as super reliable as a native USB stack. And so Tech's looking into porting picotool, which is the USB control interface way to program and communicate with an RP2040. Mass storage, you drag and drop the file, everyone knows that, but there's actually another interface next to the mass storage where you can just send control commands using like libusb, which is what the picotool does. And what's nice about that is you can do auto resets, you can query it, you can like do more complicated stuff than mass storage, and it's like much more simply defined. Like mass storage is a bit of a stack. There's a lot going on there. With the control flow interface, it's a lot simpler. So that's the next step of this. I don't know if the demo I did of this plugging in came across where it enumerates properly. So right now enumeration works, and there's actually HID support in Arduino for bitbang USB host, but I don't know how reliable it is. Again, it's a little bit of a hack. Okay, so that's the USB. So that's the RP2040 Tester Brains. Currently testing it with AVR programming. And then, we'll get more stuff going. But AVR is kind of the simplest because I wrote that code, so I know it's like bitbang. It's very simple. It's just SPI. It's working, but there's a verification issue, and I think I'm not writing to the. I think either my code's really old or I haven't programmed in a ATtiny85 in forever. It could be that my ATtiny85 programming code isn't checked out. So, or I'm there's something about you have to write fuses and then reset, and sometimes. Don't do it in the right order. So we'll do that, and then long term we'll just end up transitioning to all our testers being RP2040 based. So that's that. Okay, so next up, doing revisions. So I've been going through and QTifying a lot of I2C boards, and it's a little slow going because I've got 10-15 years of I2C boards, and I'm slowly but surely going through and QTifying them. So the ADS 1015, I think, were some of the more recent ones. And then I just did the ADT 7410, which is actually one of the last boards before we started semi-QTifying. You can actually see it's sort of got it's kind of got that shape and feel of semi-QT, but it's missing the connectors. This this is getting revised as well. So when these go out of stock, we'll order the PCBs and implement a new revision. But this board is ancient. I mean, this is product 292. This is one of the first, pick and place products we made. It's a little chunky, and used older 0805 parts. There's a couple design decisions that I wouldn't have made these days. So I wanted to QTify it. If I'm going in and you can even see it's got the old logo. If you're QTifying something, it's well, we might as well. Let's see. Let's open it up. Let's do a bunch of stuff to it. So I think it's Rev B. Hold on. Okay. So this was the older version. So you would connect through the terminal blocks only, and there's header, and there's one mounting hole. And then these were all individual resistors. And if you remember last week we talked about resistor packs. It's cheaper and easier to pick and place with a resistor pack because you have only one placement instead of having the head go back and forth 4 times. One for actually six times for each resistor. Plus, I wanted to add level shifting and boosting. So one of the things about LCDs is there are 3-volt LCDs, but there's still a lot that really want 5-volt logic. The backlight, sometimes you can give it 3.3 volts, but the LCD itself really wants to sometimes have 5-volt power. And there's different chips that are all compatible, but like there's no guarantee that the one you have is necessarily going to work at 3 volts. And so I wanted to make sure that if you're using STEM QT, because it can be 3 or 5 volts, there's no guarantee that you're getting a 5 volt power through the STEM QT port, because you plug into your QTify ESP32, 3 volt power, 3 volt logic. And so I added a little charge pump converter. So this, it just gives you, again, 100 milliamps at 5 volts, but you only need 500, 100 milliamps. You don't need that much current. It's not very power efficient, but if you're using a character LCD, you're probably not worrying about power efficiency so much. It still has the terminal blocks at the same location, which meant, I could put one QT port here, and then this is the level shifter, right? Because it's 3 volt that converted up to 5 volts. It's actually backwards than usual, right? Usually it's like input can be 5, and then you reduce it down to 3. This is like input can be 3, and I bring it up to 5. So this is a level shifter up to 5 volts. The little booster gives you 5 volt power. And then I actually had a little bit of a spot here, which was originally just empty. Turned out, this is not a bad spot to stick a secondary STEM QT port, which is kind of nice because it'll stick down past the LCD. I still have the address pins, and then you can see I replaced the individual resistors with a resistor pack. And then this is a little bit of a hack. Originally this was one transistor, but because I had the level shifter circuit that uses a dual BSS 138 N-channel FET, even though I'm not using the secondary FET, it's cheaper, again, to use the same component twice, even if you're not using the whole thing, because, one less BOM item is one less wheel you have to load in, and that, should be able to power the backlight. So this should be, basically pin shape, everything, all the holes, all the connectors are in the same spot, but I just kind of like shifted things around to make room, and I'm still using the same chips. And then I had a little bit of space. I actually had another hole, even though this hole isn't for mounting. This hole matches the LCD mounting hole. This is actually just for testing. When we do test, I want to have it go onto a pogo pin bed. It's really annoying to do that when there's only one hole. If there's 2 holes, which is like I try to have always 2 at least mounting holes on every board, especially one this big, that way it self-aligns, and then when you press it down onto the pogo pins, it's a lot easier. So this is just I'll show on the overhead real fast what the board looks like. And then we can go into the great search.
All right. You ready?
Yeah.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses her power of engineering to help you. Yes, you find the things that you need on digikey.com. Ladyada, what is the Great Search of the week?
Just a good question. This week's Great Search is looking for a newer, better trim pot. I'm revising this design, the I2C LCD backpack. Originally, I used the least expensive trim pot I could get, which is a perfectly fine trim pot. But let's look at how we can improve it. So let's go to the overhead and I'll show it off. So this is a board that connects onto an LCD and gives I2C SPI interface. And I have to do a revision for this anyways. Ironically, not because the chips actually ended up coming back into stock, although the TSOP version is a little bit more available. So I might still change this up for a TSOP, depending on whether the SOIC versions, appear magically on DigiKey anytime soon. But I changed these to resistor packs, and I, changed these connectors. And then one of the things I really wanted to change was this little trimmer. So there's a contrast adjustment for character LCD displays. You usually only have to, trim them for the first time you get them, depending on your temperature and voltage power supply. And I use these little mini metal trim pots. These are Bourne's TC33Xs, which are extremely common, right? They're very inexpensive, and they're very easy to pick in place, and they're very reliable. Only thing is that they're a little annoying. Like, they're quite small, and if you don't have exactly the right, you can't use Phillips, even though it looks like Phillips. You need to have a flathead, so it's a little confusing to people because they get the wrong screwdriver, then they get the flathead, and it has to be exactly the right size flathead. It's kind of hard to tell what size it is. So I thought, maybe this would be a good opportunity if I'm going to revise the board to maybe pick a slightly better trim pot. I want something, durable, about the same size. I have a little bit more space, because I did shift around some parts. 10K trim pot, but I want it to be a little bit easier using the TC33X. So let's go to the computer. All right, so this is the board, and again, here is the trimmer. You see, I have a little bit of space, right? It doesn't have to be as small as it is here. So let's go to DigiKey, and we will look for trim potentiometer. So the hardest part of this is to search to spell potentiometer right. Okay, so trimmer pots. Note that there's thumb wheel, there's kits and stuff, but we want trimmer pots. And trim pots come, again, there's the through-hole type. This is, through-hole, screw adjustable, multi-turn, all sorts of stuff. But usually they don't have a knob, right? That's kind of how I would differentiate a trimmer versus a non-trimmer pot. So first off, the resistance, I do need to have it be 10 kilo ohms. So I might as well just, and it's the most common value, so let's just pick that off the top. Number of turns, only one turn. I don't need a high precision. You're going to pay, it's one turn, and then price goes up very high the moment you start doing multi-turns because it's mechanically more complicated. It has to be wire wound instead of just having a sheet of resistant material. And of course I want to only search for active, and then only surface mount because I want to be able to pick and place this component. So what's really nice is that you can see most of these selections are already kind of coming into play, and I only have 76 options to pick from, which is great. So if I search by, just by price, real simply, you will see the one that I use on the board right now, the TC33X. Again, totally fine trim pot, lovely trim pot, love it, but it is a little bit challenging to use if it's the first time you've had to adjust a pot. It's good for engineers, not always very usable for beginners and makers or people who, are not as agile or have a full screwdriver set. But that said, these are very close. So let's also look for only ones that are normally stocking. And I don't want to look at Marketplace. I'm just going to look at what's available from DigiKey. Thankfully, trim pots were not strongly affected by the chip shortage, so they do have a lot in stock. So there's a couple of really good options. So this is getting a lot closer to what I want, right? It's still a surface mount trim pot, and so it can go through the oven and everything, but it has a very clear slot. It's very clear, you need to use a flathead, and you twist it, and it's a little bit more compact. This is kind of open frame. It's a little bit whoa, what's going on? And there's a few. There's these ones also from Borns, I think. Yeah, Borns. These are Philips compatible. There's actually quite a few from Nidec and Borns. For my initial prototype, I ended up just going down with the 3314J because I happen to have some. But looking at it now, I'll tell you actually why I'm thinking of changing. So this is kind of the most common trim pot, the 3314 series. But the thing about trim pots is that it's a mechanical interface, much like a normal through-hole pot or terminal blocks, and you really do want, or USB ports, you want to have some mechanical strength because it's not going through the PCB. It's surface mount, so it can shear very easily. And so what I actually liked was, I saw this one, but then this one I'm digging because, although they're both pretty good, this one goes underneath, but this one I really liked that it had these legs that stick out, and I can get really nice chunky surface mount pads, and I feel like that could give me a really good mechanical strength that'll protect against shearing when, because somebody they twist, maybe they keep twisting a little bit too much, they could shear the pot off the PCB. So I actually ended up, and also another thing I like, it has 85,000 pieces in stock. Can't argue with that. So the Nidec Copal ST4ET series, this is my pick for the Great Search. This is what I'm going to go spec into my board. It's also not too big. It's only 5 millimeters by 5 millimeters, which is well within reason for fitting on that PCB. Do watch out. The scale, it's hard to sometimes tell the scale. These can be 10 6 to 10 millimeters. But this one is a nice size. I think it's mechanically stable, and I think it's really clear. Use a flat head, and it looks like it'll be very easy for people to use.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
And that's our show for this week. Stay tuned this week on Ask an Engineer for some surprises, updates, and more. And that's all I'm going to say, so you'll have to tune in. Lady Ada, say goodnight.
Good night, everybody.
Bye-bye.